Here we're looking at another problem from WebWork. As the story tells, you're going to ask a neighbor to water your plant. The plant's not in good shape, so it's likely that it'll die no matter what, but it's more likely that it won't survive if it doesn't get watered. In this particular case, here is a tool that is powerful in handling some probability problems. Here's the idea. There's a time that's going on. So the first thing that happens is either the neighbor waters the plant or does not. Let's look at the problem. Without water, the plant will die with a probability of 0.7. So let's say that this branch is the branch that the plant does not get watered. And so one of two things will happen if it doesn't get watered. It will either die, which will be 0.7, or it will live. It'll be 0.3. Now on the other hand, if it gets watered, let's look at more of the details. You're 84% certain that the neighbor will remember to water the plant. So that means that there's an 84% chance that the neighbor will water the plant, and therefore a 16% chance that the neighbor will not water the plant. Now, if the plant gets watered, what do we know? With water, the plant will die with a probability of 55%. So there's a 55% chance that the plant will die, even if it does get watered. That means that there's a 45% chance that it will live. So there's really four things that can happen. The plant gets watered, and then it lives, or the plant gets watered, and then it dies. Or the plant does not get watered, and it still lives, or the plant does not get watered, and it dies. So one of those four things happen. The probability that it gets watered and that it lives is going to be the 0.84 times the 0.45. Now you can calculate that yourself. 0.84 or 0.55 is the probability that it gets watered and then it dies. 0.84 times 0.55. Now these are and situations, that it gets watered and it lives, it gets watered and it dies. So those are sometimes written like this: the probability that it gets watered and, that's the intersection symbol in mathematics, and it lives. Okay, that's this first choice. The second choice is the probability that it gets watered and it dies. Now down here, this is the probability that it does not get watered and yet it still lives. The probability that it no water and lives, that's going to be a 0.16 times 0.3, and down here it'll be a 0.16 times 0.7. Now it's not surprising that if you multiply all these out and then add them up, the total is going to be 1, because those are all the things that can happen. That's got to be, you add up all of those probabilities and it's got to be equal to 100%. One of those things does have to happen. Now in this particular problem, we're asked the following. You come back from vacation and the plant is dead. So once you get back from vacation, already you know something, and that is that the plant is dead. Now, how can that happen? It's one of these two things then. It's either this or it's this. Okay? It either got watered and then it still died, or it got watered and it did not die. Now, what we're asked to find here is what is the probability that the plant died because the neighbor forgot to water it. So here's what we're looking for. We're looking for the probability that the plant died, and here's the notation that's used, given that it was not watered. Okay, I'll write not watered like this. Watered with the bar on top, meaning that it was not watered. Okay, maybe I should have called D and L live with a bar on top. I don't know. Sometimes a bar on top means that it's not that condition. So we're looking for the probability that the plant dies given that it is not watered. Okay, so that's a matter then of counting up all the ways that the plant I'm sorry, this is wrong. We're looking for the probability. What's the probability that the plant died because the neighbor didn't water it? The thing that we know is that the plant died. We're looking for the probability that it was not watered. Okay, my error up here. This is really the probability that we're looking at. The thing that's known is that the plant died. Okay, this is the given. What's the probability that the plant was not watered given that we already know that the plant died? That's our situation. So what we're interested in doing here is counting up all the ways that the plant could have died. That would be 0.84 times 0.55, this is a times sign, times 0.55, plus 0.16 times 0.7. That's all the ways that the plant could die, and then we're interested in the situation where it was not watered, so that's going to be the 0.16 times the 0.7. Okay. Now if you put that amount in here, you've got that problem right.